Okay, let's try this again. Let's do another example. We're solving trig equations. This time I'm going to work this equation. 2 sine theta plus root 3 equals 0. So we're looking for which angles satisfy, which angle theta would satisfy this equation. 2 times the sine of some angle plus the square root of 3 equals 0. So again, we're going to treat this. We're doing this 3 times here. I've got 3 different ideas. So we're going to find every single angle for all time. We're going to do the same thing for radians. Okay, so you can do it in degrees. We'll do degrees first. That's easier. Then we'll try it in radians. And then we'll just restrict that if we decide on our own, I only want to know the angles between 0 and 2 pi. In other words, just one rotation around the unit circle. All right, so this is the same idea. This is an equation, so we're going to treat it like an algebra equation. Let's solve. Let's get as close as we can to that theta. So I'm going to subtract root 3 from both sides. Okay, so that's going to give you 2 sine theta equals negative root 3. And then let's divide by 2. So that will give me sine theta is equal to negative root 3 over 2. All right, so knowing our special rights, I'm going to draw a special right over here. Triangle, okay. Which special right would give you an opposite over a hypotenuse of a root 3? That would be 60 degree, root 3 here, 2 here, 1 here, okay? Opposite of 60 is a root 3, okay? So that is a 60-degree reference triangle everywhere that the sign is negative. So let's draw our unit circle here. Okay, let's draw it over here. Where is the sign negative? Again, the sine of an angle is equal to y over r. The radius is always positive. So if you're looking for negative sign ratios, that would be where all the y's are negative, and that would be in quadrants 3 and quadrant 4 down here. So let's draw our triangle in here. Quadrant 3 and quadrant 4. All right, and we already determined that it is a 60-degree reference angle. So we'll put those 60 degrees in quadrant 3 and a 60 degrees in quadrant 4. So when you're going around here, you're going around the unit circle from 0, going all the way around. Okay, that's going to be right here. It's 180 degrees, right? 180 plus another 60 would give you 240. And then you keep going around the circle and you're hitting it at 300 degrees right here. Okay, so these are the 2 places on the unit circle right here and right here where your sine is going to be equal to a negative root 3 over 2. All right, so here's your answer then for every single one. It's going to be, your angle's going to be 240 degrees plus or minus every forward or backward rotation for all time. Remember, this K stands for 1, 2, 3, 4, 5, even 0, right? 240 degrees plus 360 times 0 is just 240 the first time around. 240 degrees plus 360 times 1 is 240 plus 1 rotation around. 240 plus 360 times 2 is 240 plus 2 rotations forward. K can also be negative, -1, -2, -3, so backwards rotation. Or you have, every time you hit the 300-degree mark, plus or minus every forward or backward rotation. Okay, so that would be your answer for all time. Okay, forward or backwards. Now, part 2 of that question was, let's do it in radians. Well, that's easy enough. We've already solved this. We know that it's just 60 degrees. So what is 60 degrees in radians? 60 degrees is equal to, remember pi is like 180, right? 180 divided by 3 equals 60. So this is just, let's do this in a different color. Maybe let's do this one in pink or something. So it would be pi over 3 over here, or pi over 3 here. 180 is the same as pi. Pi is the same as 3 pi over 3, right? 3/3 is the same as 1. So 3 pi over 3 plus pi over 3 is 4 pi over 3. And then if you keep going around, 2 pi is the same as 6 pi over 3, right? To multiply by 3/3. Okay, so 6 pi over 3 backwards pi over 3. So this 300 is the same as 5 pi over 3. Okay, so here are your 2 answers in radians. It would be 4 pi over 3 plus every forward or backwards rotation and 5 pi over 3. So let's write those down. So in radians, your theta would be 4 pi over 3 plus or minus, and 360 is the same as 2 pi times every forward or backwards rotation, or 5 pi over 3. You can put these little squiggly brackets around it. That's probably how you see it in the book. Plus or minus every forward or backwards rotation. There's your answer in radians. Okay. Now, the last one is, what if they asked you, I don't want to know every rotation in all of human history. I just want to know from 0 to 2 pi. So let's just point this out. If they're putting a radian in here, they want your answer in radian. Okay, so if on like math, Excel, they give you this is, I want to know all your solutions from 0 to 2 pi, then they want you to answer in radians. Okay, so what is that? That's the easy, right? We start at 0 radians, go to here, all the way to here. So you just have 4 pi over 3. That's your first answer. That's supposed to be a beautiful squiggly bracket. I'm sorry. Let's make that cleaner, okay? And if you keep going around here, right, you hit 5 pi over 3. So that's your next answer, okay? And then you hit 2 pi. So one time around the circle, you just hit it boom, boom, twice, okay? And that is your answer for one time around the circle right here, okay? That's it. So I'm going to stop this video and do another recording.